Hello everyone, this is the second part of the factoring lesson. So far everything we've covered has been stuff that was covered to some extent in Math 2. This first thing I'm going to go over in this video is also something that was covered in Math 2, and then we're going to kind of actually get into new material here. Now I want to emphasize that there's a reason we're reviewing this with you, and this is because factoring is a skill that you are going to need in Math 3, and you have to have it down. You have to be very good at it, and this is definitely something you want to practice. It's gonna come up multiple times throughout Math 3 honors, and Math 3 for that matter. And you want to make sure that you truly have these skills down so that you're not behind and you're not struggling. All right. Okay, so let's go ahead and take a look at this guy. So first thing we always look for is a GCF, right? So we look here, I've got a 5, a 22, and an 8. There's nothing that I can pull out of a 5, a 22, and an 8. So what I have to go ahead and try and do here is we have to use a different method of factoring, which you did learn in Math 2. And this is going to be, factoring when a is not equal to 1. Okay, so previously on our trinomial problems that had a leading coefficient that wasn't 1, you were able to pull it out. But in this case, we cannot pull the 5 out. So let's go ahead. I'll copy this one down up here. I don't know why I scrolled back down here. We'll go ahead and we'll put this as our example. All right. So we've got as our problem 5x squared plus 22x plus 8. Now here's the deal. There are a bunch of different methods you can use to factoring trinomials where a is not equal to 1. You may have learned guess and check. You may have learned AC. I know they have like borrow payback method. You could have done the box method. There's a bunch of different ways to do this. The way I am going to teach you is AC method. This is the method I like the most, and this tends to be what students like the most. Obviously, you know, there are students who prefer the other methods. And if you have a method that works for you and you remember it from Math 2, you can do it your way. I'd rather you do the way that you're comfortable with. However, for the purposes of this video, I'm going to specifically only use AC method. All right. So kind of to point out, the way that a problem like this is different than a problem that we did previously is because we have this leading coefficient here that we cannot get rid of. All right, so what we're going to do is we're going to multiply the first and the last number together. And that gives us kind of our magic number here. 5 times 8 gives us 40. All right, so we got to figure out what two numbers multiply to 40 and add to this middle number here. Which is 22. So what two numbers multiply to 40 and add to 22? That is going to be 2 and 20, right? And of course, remember how we talked about in the previous video where you can sit there and list out all of your factors if you're struggling coming up with these two numbers. By all means, go ahead and do that if you have to. All right, so now what we're going to do is we are going to rewrite this middle guy using these two numbers. All right, so we leave our first guy the same. And then this middle guy, the 22x, we're going to rewrite as 2x plus 20x. All right. All I did is rewrote it using those two special numbers. And then we leave our guy at the end here. Now, at this point, we're actually going to do something called factoring by grouping, which we're going to do later in this video. And what that is you look at the first two terms and you see what you can pull out of those two terms. So you're essentially just finding the GCF. So here we've got, we can't take anything out of a 5 and a 2, but we can take an x out. So when I do that, I am left with 5x plus 2. All right. Then we're going to look at these two and take out a GCF there. So a 20 and an 8, I can take a 4 out. Now, one thing you want to be kind of aware of is when you're doing AC method, this guy always has to have a sign. All right, normally, like when we pull a GCF out, you know, notice how like I didn't put a plus x here, right? We just put an x because it's positive. This second guy, he always has to have a sign, all right? If it's a positive, put a positive. If it's negative, put a negative. And you'll see why later because we end up having to use that sign. So we divide these by 4, we get 5x plus 2. Now, something that is important here is these two, whoa, what the heck? These two guys need to match. All right. If those two binomials do not match, you messed something up. All right. Maybe you didn't factor correctly. You didn't take out a GCF. Something, or maybe it's not factorable in some cases, right? But if you're doing this correctly and it is in an AC factoring problem, those guys should match up. So now what you do is you take this guy and this guy, and they're going to become a binomial. So this is going to be x plus 4. All right, you put him there, you put him there. All right, and then the second guy, this binomial that's written twice, you literally just write him once. So 5x plus 2. So our answer here is the two things we pulled out times this binomial that repeats. So that is our answer here for, what were we on, 25. So we do 5x plus 2 times x plus 4. All right, so let's go ahead and try number 26 here. All right. So, of course, we always look for a greatest common factor. There's nothing I can pull out of a 2, 7, and a 3, so we have to use a C method because our A is greater than 1. So we're going to go ahead, multiply the 2 and the 3, and we get a 6. So what two numbers multiply to 6 and add to 7? That is going to be 6 and 1. So we take these two numbers and we rewrite the middle guy. So we do 2x squared plus 6x. Now you could do just plus x, or you could do plus 1x. It doesn't really matter. Plus 3. All right. So at this point, we go ahead and do our factoring by grouping. We pull a GCF out of these two guys. We can take out a 2x, and I'm left with an x plus 3. All right. Now, this points out, or I guess this brings up a very common issue that comes up. If we look at these guys, right, there is nothing I can pull out of a x and a 3. Like, there's literally nothing I can pull out, okay? So what you want to do there is when you're doing AC factoring, you have to pull something out of that second guy. So if there's nothing you can pull out, just pull a 1 out. And you'll see, right, this guy already matches that, okay, which is good. So we write our final answer. We take these two guys and make our binomial, so we get 2x plus 1. And then we rewrite that guy that's written twice just once. And that is our answer there. Alrighty. Next one. Let's try 27. So first, of course, we look for a GCF here. There is no GCF. So we got to go do this times that. And in this case, we get a negative 4. So what two numbers multiply to negative 4 and add to 3? So those two numbers are going to be let's see, negative 1 and positive 4. Right? So we rewrite 3 using a negative 1 and a 4. So we will say 2x squared plus 4x minus 1x, or minus x, minus 2. All right. Then we go ahead, do our factoring by grouping. We can take a 2x out, and we are left with x plus 2. Now, here it looks like there's nothing we can take out, right? It's just we've got a x and a 2 here. However, when you're doing AC factoring, this is another thing you got to watch out for. If this first guy is negative, you're going to want to pull a negative out, right? So instead of taking out a positive one, since there's nothing we can pull out, we're going to take out a negative one. So again, whenever this guy here, the first guy in the second group is negative, you're going to pull a negative out. So we end up with a positive x plus 2, right? Because we got to divide each of these by negative 1, right? So our answer here is going to be 2x minus 1 times x plus 2. Alrighty. Let's go ahead and we're going to skip to question 30. All right. So looking here, if you recall, first thing we got to look for is a GCF. All right. And this one actually does have a GCF. I can pull out a B. All All right. So now we can go ahead and we're going to, of course, try and factor this further, which we can do. We're going to use AC method here. So we do 3 times 16, and that is going to give us a 48. So we got to figure out what two numbers multiply to 48 and add to 26. So let's see. This one I actually don't know off the top of my head. 48... Yes, there we go. It took me a second there. We're going to do 2 and 24. All right. Because those multiply to 48, add to 26. Now, one thing, don't forget this B that we pulled out. Just leave it out in front. Okay, we'll kind of ignore him till the end. But don't forget about him. He's still important. But we're going to continue factoring all this other stuff. So we've got 3b squared plus 2b plus 24b plus 16. All right. So we got to take out our GCF, or I should say we got to take out the GCF between these two terms here. And that is going to be just a b. So we're left with 3b plus 2. And then here, let's see, a 24, we can take out an 8, right? A 24 and a 16. So we're going to take out an 8, and we get 3b plus 2. And of course, you want to make sure that these guys match up. Let's say you messed this one up, okay? Because I would say an easy way to kind of mess this problem up would be like, oh, a 24 and a 16, I could take a 4 out, right? So when you do that, you end up with a 6b plus 4, and these don't match up, right? The reason they don't match up is because you didn't actually take out the greatest common factor of that second guy. You just took out a common factor. So it's no good. I just want to show you, like, what happened, what it looks like when you make a mistake. So we'll go back to the correct answer here, which was 8 times 3b plus 2. So now we've got this b on the outside, right? And then these two guys come together, and we're going to get b plus 8. And then this guy that repeats, we're just going to write him once. And that is our answer there. All right. Okay, let's go try number 31. Okay, so we look here. What's the first thing we always look for is a greatest common factor. Now, if you recall, I told you if this leading term is negative, you're probably going to want to pull a negative out. So we know we're going to take a negative out here. Let's see if we've got 10, 82, and 16. 82 is kind of an odd one. It looks like the highest number I can divide all of those by is just going to be a 2. So I'm going to pull a negative 2 out, which is going to give me a 5h squared plus minus 41h plus, and then we get 8. All right. So at this point, we have to check to see if we can factor this guy further, right? Which we can. He is a trinomial, quadratic. We're going to try and use AC method here. So 5 times 8 gives me 40. What two numbers multiply to 40 and add to negative 41? That's going to be a negative 40 and a negative 1, right? So we go ahead and we're going to rewrite this as a minus 40h minus 1h plus 8. And again, don't forget about this 2 just hanging out outside. Look at these guys. Here I can take, I'm going to do that where I do the kind of the factoring by grouping. And here I can take out a 5h. So when I do that, I am left with an h minus 8. Now, remember, on the second grouping, if the leading coefficient is negative, pull out a negative. And there's nothing we can pull out of a 1 and an 8. So we're just going to take out a negative 1. So we get h minus 8. All right. So now we can go ahead and write our final answer. We're going to leave our 2 from the outside there. These two guys come together, and we get 5h minus 1 and times h minus 8. And that would be our final answer. Alrighty, we're doing all right here, my friends. Okay, so now we're going to move on to a factoring method that actually is going to be new for you. All right. And that factoring method is, it's known as sum and difference of cubes. Okay. So if we look at this guy, all right, at first it looks like we can't really do much with it, right? There's no GCF. You might like want to attempt to do like a difference of squares here, but it's not a difference. And you also cannot, you can square root the 1, but you can't square root an s cubed or a 27. So it almost looks like we can't do much. However, this is going to be a sum of cubes, okay? So we're going to go on up here to our summary chart, and we're going to write down another one. Okay, so for a sum of cubes, go ahead and copy this formula down. Now, there's actually, we have both a sum of cubes and a difference of cubes, okay? Right now, we're just doing sum of cubes, so go ahead and copy that down. And basically, you know you have a sum of cubes when you have two terms being added together that you can cube root, all right? So, in this case, we have 1 plus 27s cubed. The cube root of 1 is 1, and the cube root of 27, I should say cube root of 27s cubed is going to be 3, and then whenever you're like cubing something, or cube rooting, I'm sorry, when you're cube rooting something, you divide the power by 3, right? So 3 divided by 3 is 1, so we just get 3s. Okay, now if we are following this factoring pattern here, right, if this is our a cubed and b cubed, that means that our a value is going to be 1, and our b value is going to be 3s. So we're going to go ahead and plug this in to this formula here, okay? So we're going to do 1 plus 3s, and then we have a squared, right? So I'm going to write where everything goes in, and then we can simplify it later. So a squared is just going to be 1 squared, and then it's minus a times b. So it's going to be minus 1 times 3s. And I'm running out of space, of course. Way to go. Sorry, guys. And then it is plus your b squared, so that's going to be 3s squared here. All right. So now we could just simplify. The first guy we can't do anything with, so he's going to stay the same. 1 squared is 1. 1 times 3s is just 3s, so we're going to do 1 minus 3s. Now, be sure when you're squaring this that you distribute. So we end up with 9s squared. All right. Now, at this point, you could go ahead and check to see if you could factor this further. A lot of the times, you're not going to be able to, and this is an example of a time where it's just not going to work out. So I guess I could show you how you could, like, try it, and then it fails. So if we had, like, 9s minus 3s plus 1, okay? That is a trinomial, right? And it looks like maybe we can use AC method on that, okay? However, if you go to use AC method on this, we end up having to try and find a number that multiplies to 9 and adds to negative 3. There are no numbers that are going to do that, right? Because the only way we're going to multiply to not, like a positive 9 add to a negative number would be like if we had, we can do negative 1, negative 9, and negative 3, negative 3. Neither of those pair-ups are going to add up to negative 3, so we can't, this is not factorable, okay? So we stop here. So that is our answer for, where was I at? This guy. So that was 1 plus 3s times 1 minus 3s plus 9s squared. All right. Let's go ahead and we shall try this next one here. So again, I look at this and I'm like, this looks like a sum of cubes here, right? So we're going to go ahead and take the cube root of each of these. All right. Now, if you don't know how to do a cube root on your calculator, well, first I should say, right, we're going to look for a GCF. We don't have one. So to do a cube root on your calculator, you're going to click math, and then you can go down to this number 4 here. And we would just type in 125. Square root of, or cube root of 125 is 5, right? So if we're following this pattern, right, if our a cubed is 125 t cubed, a is just going to be 5t. If d cubed is equal to, or I'm sorry, if b cubed is equal to d cubed, that just means that b is going to be d, right? Because if we're following that pattern, this is our a cubed plus b cubed, if you look on your summary sheet, right? So we now know what a and b are, so we could just go plug it into that formula there, right? So we're going to do a plus b, which is going to be 5t plus d. And then this is going to be times a squared plus minus a times b, which is going to be 5t times d, and then plus b squared, which is going to be d squared. All right, so we can go ahead and try and simplify this. So we've got 5t plus d. Oh, I forgot to square that guy. Sorry, I think I said it, but didn't do it. So then we have to go ahead and distribute that, and we get 25, and we end up, oh, this is, okay, I see what I did. I forgot to put the squared on the outside. That's a big boo-boo. Sorry. That's not good. So we go and distribute that. We get 25t squared. When we multiply this, it's just 5td plus d squared. All right. And at this point, we are done. Now, another factoring method that we could use here is going to be difference of cubes, okay? And it's very similar to what we were just doing. Well, actually, let's go ahead and we'll do 35. I like this one a little bit better. So that's 8 minus 27v cubed. So go ahead and copy down the factoring pattern for difference of cubes. The only difference here is that they like switch the signs, okay? So nothing too crazy. Actually, hold on, difference. I was going to say, I was looking at this, I'm like, this doesn't seem right. This should be, I never changed this. I'm a goofball. Okay, everyone, go fix this right now. Holy smokes. So, this should be a minus sign here, and this should be a plus sign. I thoroughly apologize. I'll be honest with you. What happened was I copy-pasted the sum of cubes and then never edited it. So, oops. So make sure you guys fix that on your sheet. Okay. So, our problem here is 8 minus 27v cubed. Now, how do I know this is a difference of cubes? Well, first you look for a GCF. Do we have a GCF here? No, we do not. And we have two terms that we can take the cube root of, okay? So that's what we're gonna go ahead and do here. And we end up with a cubed being 8, which means that a is going to be, when we take the cube root of 8, we just get a 2. And b cubed is going to be 27v cubed, which gives us 3v. So now we just go plug all that into the formula. So we are going to do 2 minus 3v, and then we get 2 squared plus, and then we've got 2 times 3v plus, and then b squared, which is going to be 3v squared. So now we just go simplify that. We get 2 minus 3v. 2 squared is 4, so we get 4 plus, and we multiply this, we get 6v. Plus, and then we get 9v squared. And that is our answer there. All right. I am actually going to skip questions like 36 to 38, just for the sake of time. I feel like I'm more concerned about you knowing how to do 39 and 40. So let's go take a look at 39. Now 39, so far it doesn't fall into any of the categories we've looked at, right? Because we've looked at 2 terms and 3 terms. So first things first, we always look for a GCF. There isn't one. So if you do not have a GCF, we are going to use a method, attempt to use a method that is known as factoring by grouping. So let's go to our 4 terms here, and we are going to use factoring by grouping. So let's copy down problem 39 here, which is 3x cubed plus 5x squared minus 30x minus 50. Now, I don't know why I wrote 150. Here we go. So, generally, factoring by grouping is you're gonna be able to use it on cubics, but not all the time, right? And it's just basically these different factoring methods are kind of like tools you can use to attempt to factor something. Sometimes they're just not going to be factorable, but we're going to go ahead and make sure that we explore all of our options. So factoring by grouping is actually going to be very easy for you now because you've already learned how to factor using AC method, which it pretty much is just that without the AC. So you just look at your first 2 terms and you pull out what you can. Here my GCF is going to be x squared. All right. So then I am going to be left with 3x plus 5. Now, I'm going to go ahead and look at my next 2 terms here. I've got a negative 30x and a negative 50. Now, if you recall with AC method here, if this second guy is negative, you want to pull out a negative, right? So let's see, 30 and 50, we're going to pull out a negative 10. So we're going to be left with a positive 3x and a positive 5, which these guys pair up. So we are left with x squared minus 10 times 3x plus 5. Now, this guy kind of looks like a difference of squares, right? Doesn't he almost look like he could follow that pattern? If he was a difference of squares, you would factor it further. Sometimes you do have to factor further. However, you cannot square root 10, okay? If it was, let's say, a minus 16 there, then you could do, x plus 4, x minus 4. But 10 you can't square root, so we are done. However, you do got to keep an eye out for that because there might be problems where you do have to do that. For example, number 40. So we've got our 4 terms. We look to see if we have a GCF we can pull out. We do not. So we're going to go do our factoring by grouping. So we've got a 16 and an 80. We can take out a 16 from there, actually. So we're going to take a 16 and an x squared out. So we're going to be left with x plus 5. Then we look at the second group here. Again, this guy's negative. You got to pull a negative out. The GCF here is going to be 9. So we're going to pull a negative 9 out, and we get x plus 5. So now we're going to go ahead and rewrite this. Remember, you take this guy and make a binomial. And you just write this guy once. Now, in the previous problem, we were done. However, this guy, we can factor further. He's a difference of squares, right? We can square root 16x squared, and we can square root 9, and it's a subtraction sign, so it is a difference. So when we factor this guy, we end up with 4x plus 3 and 4x minus 3. And that's just times x plus 5. This is your final answer. If you gave me this as your final answer, that's incorrect because it's not factoring it completely. You factored, but you did not factor it completely.